DevReach, hi! Welcome, everyone. Oh my goodness, it's amazing to see your faces. I am so humbled that you all chose to spend a couple days with us just celebrating and learning more about the upcoming technologies in our industries. So thank you so much for being here.
We are so glad that you're here, and we also want to make sure that we thank our wonderful sponsors, 356 Labs, Kincarta, and gapmobilize.net, along with, of course, our premier sponsor, Progress.
Woo. So quick word from Progress.
Welcome to DevReach. I'm Yogesh Gupta, President and CEO of Progress Software, and I'm honored and delighted to share with you some of the brightest minds in the tech space. So I hope you learn, connect, and enjoy everything DevReach has to offer.
So a big round of applause for all our sponsors. Thank you so, so much. Now, I am super pumped to introduce our keynote speaker, VP Director Program Management for Azure Microsoft. Scott Hunter is responsible for Microsoft.NET's platform, which includes the .NET framework and so much more. In his spare time, he loves to hike, and I'm actually really curious, because he's been hiking all around the world. I'm curious if he's hiked the mountains of Bulgaria, so we'll have to find out. But please, please put your hands together for our incredible opening keynote speaker, Scott Hunter.
Okay. Excited to be here. First time in Bulgaria. Super excited to be here today and talk about some of the new stuff we have coming in .NET. The talk is a .NET 8 talk, a little bit. I'm going to talk about some of the cloud-native parts of .NET, some of the AI parts of .NET. There's other parts, folks from Microsoft here. Maddie and David from the Maui team are here, and they'll do some presentations as well on Maui. We got Jeff Fritz, and he's doing some presentations on ASP.NET. Thank you for the introduction. I'm Scott Hunter. I'm the VP of Product at Microsoft on our Azure Developer Experience team. And let's get into a couple of .NET things. So we started this vision back in 2014 when we rebooted .NET to basically build a platform for building any type of application. You know, we don't care if you want to build a mobile app, you want to build a web application, a console application. And we wanted to have a unified set of tools, VS and VS Code, or even command line if you're on Linux or a Mac. And then, of course, we support all the platforms, Windows, Mac, and Linux. And not only do we support those platforms, we support them on x64, x86, ARM32, ARM64. We've done a lot of work in the ARM space the last couple of years. Once we did that reboot in 2014, we're at a point now where we have about 6.1 million developers for a 21-year-old tech, which I'm pretty excited about. We've been growing at a great pace year over year. The most important thing for us is we've taken 53,000 things from the community in open source. So we open sourced in 2014. So we were really, really late open sourcing. But it's amazing to see that we've had 53,000 people actually contribute to the platform over the last couple of years. .NET's always been in the Stack Overflow Developer Survey. We've always been in the top 1, 2, or 3 for the last couple of years. If you look at the Cloud Native Foundation, which measures the velocity of OSS projects, this is how many issues, PRs, and stuff are actually happening inside of GitHub. We've been in the top 5 for the last couple of years as well. And C# is the number 5 language, the top 5 language in GitHub. Speaking of that, before I even do performance, let's jump to C# and just start with C#. C# 12 ships with .NET 8, and it's got a couple of features that are really, really cool. I've been focusing on the last couple of years how we actually have less ceremony. Not only do we want to make, I said before, .NET's been around for 21 years. We want to make it as just approachable for a JavaScript customer or a Python customer as it would be for a C++ or Java customer. And so to do that, we've been getting rid of a lot of boilerplate and simplifying our syntax for the last couple of years. I'm going to talk about one huge feature, which is called primary constructors, that I'm going to show. And I'm also going to show what I call collection literals. And these are just ways that we make our language cleaner. And so with that, let me jump over and show some code here. So first off, I'm going to use a tool called sharplab.io. It's a really cool technology that actually takes the code that you see on the left here and shows you what the compiler actually makes for that code. And so one of the things we did a couple releases ago is, as I said before, we're trying to make .NET more approachable. So we've had, this public class, this main thing. I can get rid of these things. I can just come over here and just do this. We started doing this a couple of releases ago. What's kind of cool about this is when I do that, notice that the compiler still goes and generates that static void main, that class program. I can just write my code. And so this is part of something we shipped around .NET 6, where I don't require anything. I can just start writing code inline in the actual application. And I like to show how that actually works. And so this is kind of just showing how that works. But let's jump over to my app, and I'm just going to copy and paste a couple things over here. So this is primary constructors is one of my favorite features that we have in C# 12. And so what I'll do is I'll just paste this class over here. This is what you would expect. I've got a class, I've got a constructor, it takes some parameters, and all it does is assigns those parameters to the various properties. You've seen this a million times. In C# 12, we can simplify this. And I'll just copy paste it. It's faster than me typing in line here. I can take that and replace it with this. So in this case, I've actually now made the class definition have what we call a primary constructor. It's got the X and the Y's right there. And so I get rid of all that method. And I'll show you in a second why that's important. But what's cool here is if I go and get rid of this, and we go look what the compiler generates, it's going to basically generate the same constructor that we've always had. So once again, this is just making the compiler better and letting you write less code to get your job done. And this really applies, and I'll show you why we did this. We're always sitting around looking at the code that we have. And a really common thing when you're building web applications is, in this case, I'm going to use dependency injection to inject a logger. Almost every ASP.NET web page is going to have this. So you see here, I've got my page, and I've got my private logger variable, and my constructor takes this thing. Every single application, every single web page has this same chunk of code. And so the idea behind primary constructors was, let's just get rid of that. Let's just take this. I can move it right up here. And then I can erase all this junk. What do you think? Is that good? I think that's awesome. So literally, this is us looking at our code every day and asking, why do we have the same boilerplate code in all these places? And so this is a thing that we're doing in the product. So let me go switch back to some of the code here. And let's show the new literal tech we have in C# 12. It's okay to save that. So I'll just copy some other stuff here. Just copy a chunk of this stuff, and we'll paste it over here so you can see what actually happens with the compiler. So we've always had this kind of syntax here where I can basically say, hey, I've got an int array, and I'm going to say new int array and feed it some stuff. We've got this new simplified syntax we've had for a while where I can just say int array and just give it the list of parameters, and we'll do all that other stuff for you. And you can actually see down here, if I deleted the code already, but it does the same thing. You can see there it's doing a new int 5. It's initializing the parameters. We've now added that same syntax for collections. So if you look here, I've got my traditional, list of int, and I've got my new list of int, and I give it the parameters. But if you look down here for starting with right here, once again, we removed all of that new list int stuff. We can infer that. We know you have a list of int, and you can just give us the parameters. And so this is the continuing evolution of us trying to reduce the amount of boilerplate code you have to write as you write this code. I've got one more cool kind of thing here that we've done as well. Notice that I have 2 lists, and by the way, if I go look, you're going to see the code does the same thing you would expect. It basically boots up a new list of int. We run that for you, and we just call the methods to add that stuff automatically. We're just doing it's syntactical sugar. We've got this really cool new feature where notice I have list of int f, and then I say .e.d. That basically says take the collection of e, 6, 7, 8, 9, 10, and then take d, 1, 2, 3, 4, 5, and put them in the array. So I can make these collections. I can actually then assign them in other creative ways as well. And once again, if you look down here, the compiler is doing all kinds of magic to copy those things in. And so these are my 2 favorite features in C# 12. There's other things that I have in the app that I can point to as well. We can now do aliasing. And so if you look up here, I have just taken my name and turned it into an int32. And so anywhere I want, I can declare a Scott. Because, I'm Scott. So you got to be able to declare a Scott, so I can decide now that I want to have my own Scott variable here. So that's a cool feature, but that's what's new in C#. Let's jump back and talk about some of the other crazy improvements we have in .NET. Let's jump back here. So when we decided back in 2014 to kind of reboot .NET, we asked ourselves the question, if you're a Java developer or a Node developer or a Python developer or a Go developer, I don't think Go was actually there yet, but it was close. Why would you choose .NET over any other technology? And we thought we would focus on performance. We already had great tools with the Visual Studio family of tools, and so we really focused on performance. And so you can see here, this is the number of performance improvements we put in the product every release. And you can see it's been growing at a pretty good pace year over year over year, with 1,250 performance improvements in .NET 8. Stephen Tobe writes these amazing blog posts. I'll have a URL that I'll send you in a second. They're like 30 or 40 pages that explain all the performance improvements that we've made in .NET. The link's at the bottom of the page here. But let's take a look at some of the recent improvements we have in .NET 8. So this is showing the Tech and Power benchmark. That's an open source benchmark run by an independent company. Anybody can contribute their framework or their library to that benchmark. And this is just showing that the Tech and Power JSON benchmark, that's when you have an API that returns some JSON. And if you're looking at and comparing .NET against things like .NET 7, you can see we're 18% faster than .NET 7, so that's a nice improvement. You can see we're twice as fast as Go and a lot faster than Express. Over on the right, this is Tech and Power Fortunes. This is the benchmark that I really care about because it's real. It actually makes database calls. It then takes the data and kind of formats it and returns it in a real usable format. So this is what a real app would actually do. And you can see we have a 24% improvement. This means we're making improvements in our database technology. We're making improvements in all parts of the stack. And you can see it stands very, very well up against things like Go and Express again here. So those are the performance improvements that we have in .NET. You can't miss that we're kind of in this intelligent app wave right now. We have a bunch of tech that we build at Microsoft. Obviously, everybody's heard about ChatGPT. And we have OpenAI inside of Azure. My team at Microsoft, we actually build the OpenAI SDKs for all platforms. So we build them for Java. We ported the OpenAI SDK to Java. We ported it to .NET. We don't do the Python one, but we've also done the JavaScript one. We actually might do a Python one to make authentication easier. But we've also built some other technologies. We have a tech called Semantic Kernel. That's for languages that don't have lane chain support. Lane chain is a common LLM tool. It's written in Python. And as a .NET developer, I don't really want to use Python. And so semantic kernel is kind of the replacement for that for a .NET customer. And so with that, let me show a couple demos and a great blog post. So Stephen Tobe, who I was mentioning before, he's got this blog post that I would recommend for anybody, and this is demystifying retrieval augmented generation with .NET. This is literally, if you want to use AI in .NET, this is the blog post. And as I said before, Stephen likes to write lots of text, and so it goes on and on and on and on. Let's jump and show some code and see how we can actually do some of this in the real world. So let me flip over to the AI demos. Sure, you can save that. Okay. And so what I've done is I took his blog post and converted it into a very large app. And we'll start off with just a simple, I want to do a chat GPT style thing. How much code does that take in .NET? It literally fits on the screen here. So I basically new up a semantic kernel. I give it all the, these are all the API keys, endpoints, and stuff like that. You don't want to see those. I tell it it's okay to actually log it to the console. So this is just boilerplate right here. But notice that the actual loop to do chat GPT is literally 6 lines of code. We we do a prompt to ask the question. We take your response. We feed it into invoke semantic kernel a function async, and it will return the answer. So let's try this real quick. So what I'll do is I'll select number 1. We'll start with the first demo. It'll take a second. It just actually went out and actually authenticated with OpenAI. And I can say, what is .NET? And there you go. It comes back and tells me what .NET is. What is generative AI? And for fun, sometime during this demo, I will blow the computer up. So what I did there is why it blew up is my account doesn't have really good access to OpenAI. I'm only allowed to ask a question about every 4 seconds, and so I typed something too fast and it died. So that might happen again. But that was cool, but there's a challenge there. I should finish one more thing here. Let's go back here. What is the current time? Well, it's going to come back and tell me it doesn't know the time. And that's because ChatGPT is basically based on a model that was built on the internet at a point in time. And so when you ask it a question like this, you can't answer that question. So how would we fix that? Well, it's not very hard to fix that. So we'll switch to the second part of this. I'll minimize this, and I'm going to go to a custom function. And so all I've done here is, once again, boilerplate, just initialize the kernel. This time, I want to actually register a custom function. And so I can basically give ChatGPT or give OpenAI as many custom functions as I want. In this case, what I'm going to tell it is, here's a Lambda that says, when you call me, I'm going to return the date time, UTC now, and then I give it a couple of other parameters telling it what it's doing. It's called date time. It's getting the current time, the now time. So I kind of explain what that is. And then I can actually give it some more code here where I can actually tell it how to format and actually answer the question. So this is my input, and this is the output. And so then I'm back in that exact same loop again, except now, if I run this application, I can go and select 2 for date time and say, what is the current time? And now it knows what the current time is. It's actually called my C# code. And this is how you would actually train the AI to do exactly what you want. And it's pretty cool. I can think that's, what day of the week is it? Now, it doesn't know that because, well, where am I? I didn't give it enough information to know where I actually am, so what day of the week is it in Boston? And so now it's actually telling me it's Wednesday in Boston, and I can even ask things like, what day will it be in 10 days? Maybe. Yeah. So, so you can see how that works. Now, let's have some more fun with it. Let's ask, tell me a joke about a dog. Why did the dog go to the vet? Because he was feeling rough. Okay, that in itself is not super cool, but the thing here is I can ask it, why is that joke funny? And I'm sorry, I don't know how to do that. Well, why does it not know how to do that? Because I really, most of the time if you've actually tried ChatGPT, it's actually reading all the questions you've asked it. And so it's got what I would call memory. And so let's add memory to it now so it can actually do this correctly. Okay, so I love how that keeps coming back every single time. So we will scroll to the next thing. And once again, I think the thing here I think that's really exciting is I'm not writing lots of code. That's the important thing here, is our goal is to make it easy for you to use this technology in .NET and not have to write a lot of code in the process. And so now, all I've done is I've got that same kernel I always build every single time, except this time I've actually got a chat completion, and I've asked for a chat history. And so all I've done now is notice my chat history. When I ask a question, I then feed that question into the chat history. And then when I go and ask the AI for to get my message, I'm going to pass it that chat history right there. And so not a lot more lines of code here, but when I run it, now, that's not the one I want. Let's go to 3. Now it's really making me mad because I didn't change any code. Did I fix it or did I make it worse? I fixed it. Okay. So let's go to memory. Tell me a joke about a dog. And now I can ask, why is that joke funny? I'm just waiting so it doesn't time out. And the joke is funny because it uses a play on the words rough, which is a word to sound like rough. And so now my history is actually there, and so that's really cool. Now let's take the next version of this. I'll stop. And we've all seen when we do ChatGPT, it kind of does this kind of streaming thing where it's showing me this nice, cool form where I get that nice streaming response here. And so let's show that now. In this version, notice that I actually I'm adding the history like normal, and I'm doing a loop around returning that code back. So we'll run number 4. Write a poem about a dog. You like dogs. And it kind of scrolls in. So now I've got that nice ChatGPT feel to it. It feels like I'm actually talking to something, not just getting an instantaneous response back. That's kind of cool. Now let's ask a question. And it's a fun question. Is the .NET regex backtracking or non-backtracking? And so it says that it's going to use backtracking. But that's actually not true. We actually have a non-backtracking and a backtracking implementation. But it doesn't know that because it scanned the internet at some point in time. So how do we teach it more stuff? So let's think about that. So I'll come up here, and let's make that one go away. And I'm going to do what I call embedding now. So you saw before, I have that chat history. And so that's how I kind of teach OpenAI what I'm trying to actually do. Well, the way to teach it more stuff is to go put more stuff in the chat history. And so, as I said before, my friend Stephen Tobe likes to write lots of text. And so he's got his another blog post. This is not the one I wanted. He has another blog post on all of the new stuff. It's, once again, it's the performance blog post. It's the one I had right there. It's a lot of text. So here's all the performance improvements in .NET 7. That includes some of the regex stuff that was done in 7. And so what I'm going to do now is I'm going to go read that entire blog post and shove it into the buffer, and let's see what happens when I do that. So let's do memory plus embedding. I'm calling it embedding because I'm actually going to go and feed it some data. And in this case, is the .NET regex backtracking or non-backtracking? So when this boots up, it's going to go and feed all up. Something happened. I have an error here telling me the model's maximum content is 812 tokens. However, I've put way, way too much stuff into there. So I put way, way too much data in there. So how do I solve that? This is the problem. You just can't go shove all the data in your company into the chat history. You've got to go do something about this. So to do that, I'm gonna pause for a second and show a different way of doing this. So I've got a crazy version of this where I'm showing a custom embedding. And so the idea is after you leave this room today, you should be able to go and read that blog post and build all of this into .NET yourself, into your application yourself. Okay, so let's go look at custom embedding. In the custom embedding case, what I'm actually doing here is I'm actually only feeding it a couple of things. What's an amphibian? A frog's an amphibian. I'm feeding it just this much text. And then what happens is when I ask the question, I've got another method down here called similarity. And I'm doing some math to go figure out a score for those things, to figure out which ones are the best ones. And so I can actually comment out this code here real quick. And the VS I'm running is really beta, so I have to press Control S every time I do anything. So let's go look at what this does. This is custom embedding. Oh, what is a dog? And now you see it returns basically every single thing that was in my list that I had before. But if you look up there, anything that's it's a 0.90 or a 0.87 is correct, and the rest of it doesn't make sense. And so now I can take a big chunk of data, and I can start figuring out which of that data is the data that's most relevant to the questions being asked. And this is important, so I can go back over here, and I can comment this code back in, where I start limiting the similarity, saying, hey, I only want things that we feel pretty good about to be in my list. I run that again. I do custom embedding. Hopefully I press Control S at the right time. Thinking, thinking, thinking. Okay, what is a dog? Now it only returns the things I care about. What is a frog? What is a friend? Bing. So that's funny. It's not easy being green. Wow. Okay, so the next step is what I'm going to do is I'm going to do that same thing with Stephen's blog post. And so if I open up the next chunk of code here, and we do memory stringing with chunking, what you're going to see, I'm going to go basically take the blog post, I'm going to shove it into a structure that's designed to handle that amount of data, and then what's going to happen, you can see I'm doing paragraph splitting into chunks. I'm doing a bunch of chunking stuff, so I put smaller chunks of stuff in there at a time, and then it's going to do the same kind of model. It's going to basically do a similarity thing, and when I ask a question, we're only going to send to OpenAI the stuff in that blog post that matters for the question, and that's how we get the size down to the proper size. But this is going to bring up a big problem. So I'll do 7. This is everything. And now, because I'm chunking that data in, you can see that there's 163 paragraphs, and for me to slowly pump that stuff into OpenAI takes a long time. And so this is when you hear questions like vector databases come up. You want a vector database. In a proper application, what I would do is I would actually not be putting this data into memory like I am today. I would be putting this data into a vector database. And so then when I ask the question, the lookup is very, very quick, and we're good to go. And so while we're waiting for this to finish, you can see it's going to take a while. I'm going to switch to a demo. This demo is not available today. It'll be available at .NET Conf. That's in about three or 4 weeks. It's not available today because it's using a new web technology that I'm going to demo in a second that hasn't shipped yet. And because it hasn't shipped yet, we can't make the demo available yet. So it's so I can ask the question: is the .NET regex backtracking or non-backtracking? And I can ask the question. And in this particular case, it's got a vector database. It's saying it includes both backtracking and non-backtracking because it knows these things. Oops. It knows all this stuff. This is a cool app. When the app's available, you'll be able to actually run the app, publish the app. You can go to you can go to this load from the web. You can add whatever data you want, and then you'll be able to ask OpenAI whatever you've trained it to do. And we store all the data in a vector database for you in Azure, and you can easily ask questions. If I go back over here, this finally finished, and that means over here is the .NET regex backtracking or non-backtracking. And it should be able to answer the question, yep, just like it did in the web application. But obviously, you would not want to wait for that to load every time your app loads up, and that's why you want a vector database. So this is a quick intro to using AI and .NET. I hope it makes sense, and I thought there was not too much code involved in that. We actually spent a lot of time trying to go optimize the semantic kernel, so the amount of code you have to write is not super large, and I think it's pretty cool. So I am good on time. So let's go back over here. And we can talk about containers next, and we'll talk about some AOT stuff. And we'll end with a demo of some of that new web tech that I was mentioning before. So we've done a lot of work in .NET to make .NET awesome for containers. In .NET 7, we released the tech that you see right here at the very top, .NET Publish for Linux x64-C release. You can actually make containers in .NET without having to have Docker for desktop or any other tools on your machine. So you don't have to have Docker files or any of that tech. We've made it very easy for you to build containers in .NET. We've also done a bunch of work to make some of the images, the base images that we give you, very, very awesome. So we have what we call distro list chiseled images. These are base images you can use for building .NET containers that don't contain root access. They don't contain much of the OS. So you can have the least amount of tech on the actual container, which means the container is going to be more secure. It's going to be more small. So that's a bunch of work we've done in .NET 7. And we're also working on this. And this is size of container. So one of the things our customers tell us is, hey, I don't want a 7 gig container. I want a super small container. And so you can see that if we're doing like a Ubuntu 2204 chiseled container, that's one that does not contain much stuff in it at all. We're roughly in the 48 to 40 meg range for a container, which I think is really good for being able to deploy your ASP.NET applications or your .NET applications. And you can see as well, we've done a bunch of runtime work as well to shrink down the size of the .NET that we actually put inside of these things as well. And so you can see with the trimmed versions of these things being 36 megs uncompressed, 16 megs compressed. On the right there with Ubuntu 2204 chiseled AOT, and I'll explain AOT in just a second, down to 8 megs for a .NET application that's been compressed. If you told me you could put a web app in an 8 meg container a few years ago, I would have said there's no way in hell. We were at 100 megs or 200 megs per container, and we're down in the 8, in .NET 8, we'll be down in the 8 meg range, which I think is amazing. So that leads us to something called ahead of time, AOT. So AOT stands for ahead of time compile. Most of the time, if you're a .NET developer, what happens is our compiler generates IL, and then when the application starts up, a process starts and it converts the IL to whatever the native code of your machine is. If you're on a ARM64 Mac, it'll convert the IL to ARM64. If you're on an x64 Windows machine, it'll convert it to x64. And that's great. That means that .NET apps are very portable. They can run on all platforms. One app. You don't have to recompile the app for Mac or Windows. You can just take one application and it runs everywhere. But there are moments and times where you don't want that. I want to optimize this application to be as small and as fast as possible for the platform that I care about. Maybe I'm running a Linux x64 container, and that's when ahead of time compile comes in. In this case, we don't want to compile to IL. We want to compile directly to native code. This is something we started doing in .NET a couple years ago. It's what powers MAUI. It's what powers Blazor for WebAssembly. And we're trying to make it better. So those two stacks work with this tech, but we're making more and more of .NET every release work with this tech. So here is kind of where we started at. And you can see on Linux, a publish size for an application that's ahead of time compiled was about 95 megs. The working set, the amount of memory it used is about 87 megs. The startup time, 142 milliseconds. And you can see the request per second is about 800,000. Here is what it looks like today with .NET 8. Publish size, 9 megs, 10 megs. Working set, the amount of memory it requires in the container, 40 megs. And 40 megs compared to 90 megs. Startup time, because the startup time in AOT is very fast because we don't have to do that IL to native code translation, 34 milliseconds. And our RPS is close to what it was before. You notice there, you might ask, Scott, why did it get slower when you made it into native code? The reason it's slower when it's native code is because the tech that actually turns it into native code, the IL into native code, it can keep turning it into native code again and again. So what happens is in our jitter, we'll actually notice that we're running this code a lot, and it'll optimize it even more. And that's why you see that delta. The AOT is a little slower because we just compile it once and we can't ever change it again. But if you told me that we'd be in a place where I could have a .NET app that was 10 megs, self-contained, nothing else on the machine, running under 40 megs. I would have told you that was impossible a couple of years ago, but it ships today, or it ships in a few weeks with .NET 8. And so let me quickly just show you what that looks like in the tools. So I'm going to flip over here, and we'll do a console app in .NET 7. And there's nothing fancy here. This is just a Hello World console application. But I have this ability to come over here and do a publish. That's where I'll actually make the self-contained image of this. And I'm not going to do it. It takes too much time. But the big thing is in .NET 7, you see that's roughly 14 megs, 15 megs of code there. If I do the same thing in .NET 8, oops. Don't need to get repository. I do the same thing in .NET 8, I am going to get a much better size. And so you can see here's where I'm actually telling it to publish as AOT. That's the magic that makes it go and make that native image. And once again, if I go to my Solution Explorer and I go to that publish folder, I can go take a look at that folder again now. And I'm 1 meg. I mean, a .NET app, 1 meg, nothing on the box. That is, so the reason we're doing that is there are new technologies like Go and Rust that are enabling people to build these native applications that are super small. We want to make sure that .NET can do the same thing as Go and Rust. Safe language, small, fast executables. And I'll do one more flavor of that real quick, and then we'll get on and show the web tech that is really cool. So let's go down here, and I have a web app. This is literally a web API. So in .NET 8, you actually have the ability to build web APIs for the first time, native AOT. And I'll just show the same kind of thing. And we'll just go and do the publish. The publishes actually take a chunk of time. The reason I'm just opening the folders, because we're actually compiling the tech into native code. Here is a web application that's 12 megs. And that's native AOT, so it runs on the machine. It does not require anything on the box at all. And so that's AOT. So super excited about what we're doing in AOT. And let's go back here, and we'll talk about the web. So cloud native. You know, these are overused terms we hear today. Microservices, cloud native, containers. This is the CNCF definition of what a cloud native application is. I don't really care what it says, but I want to focus on what I'm going to call Project Thai. So Project Thai is something we built 3 years ago. And it was when we first started thinking about, hey, if you're a .NET customer and you want to build a cloud native app, what does that actually mean? If you're a Java customer, there's a great framework called Spring out there that has a lot of best practices and stuff like that built into it. And we want to do something like that for .NET. And so our experiment a couple years ago was something called Project Thai. And we've actually started Project Thai back. With .NET 8, we started thinking again, it's like, okay, we played with this about 3 years ago. Let's take it to the next level. And I'll build an app in a second and show you what we're thinking about and why we're thinking about it. I will tell you that I might either unplug the cable once or twice, or I might have switched to a version of the app that's more final, because I don't want to show some of the tooling that we're gonna announce at .NET Conf. But a couple of things here. It says tools for project creation. If you're building a real microservice app, that's a multi-part app. You've got a web front end, you've got a web back end, you might have a couple of components. Visual Studio and .NET aren't great at this. We have a feature in Visual Studio today where you can run more than one project at the same time, but it's clunky. It's called Startup. You can set up your startup apps, and you can drag the order where they run in. But if I've got a front end and a back end, how do I know the IP addresses of these things? What I would do today is open a launch project or launch settings and actually copy the IP and paste it in. That doesn't work. That's service discovery. We need to solve that. And then once I've got that multi-part application, we have great tech inside of Visual Studio to right-click and publish a single app but my cloud-native app's not a single app. It's a whole bunch of apps. And so we need to build some tech where our Azure tools can actually look at the app and go, oh, this is a multi-part application. I'm going to publish this to a container app. I'm going to publish this to a function. I'm going to boot up a Redis cache. And so there's a whole bunch of things we have to do to make .NET better for this. And the final one is we don't turn on the best practices by default. So if I'm building a cloud-native app for the cloud, if I just make an HTTP client, do I set retries? If I make an EF connection to a database, do I set retries? By default, we don't. And so this Project Thai thing, we're going to go set all the right defaults for a cloud app as well. And so let's go take a look at what this looks like. And this is going to be exciting tech. I cannot wait for us to show this in a few more weeks. So let's come over here, and I'll do a new project. And I'm going to do a Blazor app, and I'll call this web.frontend. And I'll call this Thai 3. And so that's my front-end application. And sure, that looks fine. And I mentioned before, you might see this moniker in my screen here. I'm on an int preview, danger, of Visual Studio, not recommended. And because of that, if I actually run this application, just making fun of myself, it's going to crash because the build that I have doesn't work. So let me just fix the app real quick. Come on. I'm glad I just said this build might not work. Let's try again. Okay. Let's do the cancel and kill. We'll just reload that and see if it's happy after that. Okay, looks like it's happy now. Glad I pointed out int preview right before that went boom. Okay, as I said, it's going to blow up by default. This is not on purpose. This is it's a bug in this version of the stuff. So I'll just come down here, and I will add the missing app dot use anti-forgery. So the templates that I have just don't have that anti-forgery turned on by default. They should, but they don't. So let's go here. Now I'm going to add a backend project here. So let's go add another project. We're going to start creating that problem I mentioned before. I'm going to create a web API, and I'll call this web.api. It's part of Thai 3. That's perfect. And so this is your kind of common scenario where you've got your front-end application. It wants to talk to the back-end application. How do I make that work in a .NET application? So by default, the front-end application is a little stupid. If I go and look at the app today, and I go here, and I go into the weather page here, it's got its fake data down here. We need real data, so I'm going to go and grab the type from the API here. We'll just grab that type. And what I'll do is I'll create, I want to make a real client. So I'm going to come here and add a new item. We'll do a weather client. We'll just call it weather client. I'll make a weather client. We'll stick it there. And what I'm going to do is I'm going to go and stick that type I just grabbed over there over here. I'll make it public. And then I'm probably going to want to make my client, it's going to want to take a HTTP client, like that. And then and once again, this is going to be using that primary constructor feature that I just talked about before. Notice I didn't make a member for it. I just passed the client in. And then Copilot is kindly pretty much writing all my code for me. I've got a squiggle here because that might return a null value, and so I can just make that go away with a little syntactical sugar there. And so I've written a client here, and then what I would do is I would go into my web page here, and I will get rid of that this fake data here. So let's go kill the fake data. And up here, we'll make this just call that code I just wrote. First off, we have to inject that type into here. So we'll inject the weather client. And we'll call it weather. And then I would just come down here and I could do my magical forecasts equals, what did I call that thing just a second ago? Weather. It would be await weather dot get forecast async. Boom. So I'm good. The only thing I'd have to do now is I'd have to go to my program CS, and this is where things get ugly, is I want to go make that, I need to add that, I would do a builder, services, or add HP client. There we go. Weather client, blah, 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 and I'm good here. Now notice, now I need to give it a URL. And so where would I get the URL for that back end? I would go get that URL from the back end. I'd go to properties, launch settings, and I would grab this URL. Well, that's where things go bad. So let's, I'm going to stop working on this, and I'm going to flip to the version of this that's actually completed. And so let's go to the demo app. This prevents me from actually showing the tools I'm not supposed to show. And so in this case, now something's happened. I've got my weather app, just like I did before. I've got these two new projects. I've got a demo app host, and I've got service defaults. So let's go take a look at what happened here. So I'm in my demo app host app, and here it is right here. And now I have a new distributed application builder. So I've got distributed application, which means I know my app's going to be multi-part. It's got more than one part. And so I'm going to create that builder. And then notice that the first thing I've added something else here as well, is notice that I've added a cache. Builder.add Redis container. And so in some cases, I might want a Postgres container or a MySQL container. You can actually build, these are built in now. I can actually go in here and create a Redis cache with this line of code. And then my API application, which you already saw us build, I'm now calling builder add project. I want to add that project to my distributed application, and I give it a name. So it's demo.api. And that API, that's the name I can actually use for my URLs now. And then my Blazor application, that's my front-end application. I'm going to do builder.add project. I'm going to add that front-end application. I'm going to give it a name too. But then notice here that I can tell the tool that front-end application needs to be able to reference the back-end API, and that front-end application needs to be able to access the back-end cache. And so what this file literally does is it tells us my multi-part application, my distributed application is made up of a Redis container, it's got a web API back-end, it's got a Blazor front-end, and I'm gluing them all together. And so because I've done this, if I run this application, it's going to run all those components for me. This file literally tells me tells the platform how to glue all the pieces together. So if I control F5 this, and let me minimize this so you don't see things you're not supposed to see. Let's give it a second here. Something new is going to happen. I'm now in a dashboard. And this dashboard's pretty cool. Notice I've got a projects tab here. And it's showing me here's my API project. Here's my Blazor project. I've got a container segment here as well. That's got my Redis cache. And we've done all kinds of good stuff here. This is my Redis cache. I can go click View Logs. There's the actual logs of the Redis cache running in Docker on my machine right there. If I go to Projects, I can click View Logs. There's the logs of my backend application that's happening right now. I can go back there. I can also do the drop down. And there's the front end. There's the back end. And of course, we're giving you access to all those URLs. So if I want to go run the back end and see what actually happens, I click that. There's my weather coming back from my back end API. If I want to run the front end, I can click the front end. And then obviously, it's making that call to my weather API. Let's go back and look at the code real quick. And I want to show a few things. In my Blazor application, that's my demo web. If I go back into my program.cs, notice that I'd made the URL demo.api. That's the exact URL that we called out inside of that app host. And then something else, if I go into my program file for this as well, you're going to notice that we actually added a builder.add Redis output cache. Output cache is something we've had in .NET for a long time, and I'm telling it I want an output cache in here. And then down here at the bottom, you'll see I can say app.use output cache. That means if I go look at my web components, go look at my go to my weather page. I've added a attribute up here, which is output cache duration equals 5. I'm saying basically telling it to cache this page for 5 seconds. I brought in the namespace. And I can tell that if I go back to the web and I refresh this page, 1 1000, 2 1000, 3 1000, 4 1000, 5 1000, 6 there it goes. You saw that was cached for 5 seconds. But this is pretty cool as well. If I go back to my views over here, I've got my logs by project, container, executable, structured. Structured's new. And so let's go take a look at one of these. I'm going to fix this to say, show me the web, the front end only. And even better, let's go to traces. It's easier to see in traces. I'll go to traces. This is something brand new as well we've done. Notice here's a call to the weather, and it's showing there's 2 things here. What's going on? So if I click and drill into this, it's going to show me the full stack. So we've actually taken logging and ran logging all the way. This is distributed logging all the way through ASP.NET from the front end to the back end. You can see that here it is. It's called the weather forecast. It got a get. So it's showing the entire stack. I can click any of these and see the information about these things, what actually happened. If I go back to my traces and I click one of these, this is going to be one of the ones. Let's go find, where's the one I want? Let's go beat the app a little bit more. I'll actually be able to go and find traces that actually show where we did not actually call the backend API and we saw the cache. There's metrics here as well. I can select my service, my demo API, and now I can see the number of service requests that are happening to my API. I can see all these metrics. And so not only what we've done is we've built this new host that lets you run multiple apps at the same time. We let you decide how they all hook together, and we've hooked logging and tracing throughout the entire thing. The last piece of this, there's also a manifest file that's generated from this, and that's where my tools can go build the right stuff to run all this in Azure for you. And so this is the extension of Project Ty, and we'll have a lot more to say about this in just a few days. I was going to quickly show something else. We'll see if the Mac actually works. Macs are twitchy when it comes to displaying stuff. One of the things that we've done that's super cool, so I mentioned before that Maddie and David are here. They'll talk about Maui. Jeff's here. He's going to talk about Blazor. Blazor is really cool in .NET 8. If you've been playing with Blazor, the Blazor I showed you, I was using server-side Blazor. There's client-side Blazor using WebAssembly. You're now going to have the ability to take an existing application, an MVC application, a Razor Page application, and you can use Blazor components in any of those applications. So now you don't have to rewrite your old MVC apps as Blazor apps. You can actually have a MVC view that returns Blazor components. You can have Razor pages that return Blazor components. And so literally Blazor components, all the cool things that the Progress folks makes, they work in all the apps now. So with .NET 8, you'll be able to use all the Progress Blazor tech in any of your applications. And hopefully Jeff's going to show that. I was just going to show one thing quickly here. This is something that we're really excited about. You might have heard we had an announcement that Visual Studio for Mac is something of the past. It's something we're not working on. You might ask why. We realized we're never going to be able to put all the features of VS for Windows into VS for Mac. That's never going to happen. And so the better place to do our investment is to do the investment in VS Code. So what I've got here is I've got a Maui application in VS Code. And while I'm just nerding out, Hot Reload has not been in the dev kit. Dev kit, if you've not seen it, that's our new version of tooling for VS Code for .NET. It is actually built on the same tech that's inside of Visual Studio. I was just, Maddie told me this morning that there's now a Hot Reload option. That it's not GA'd yet, but you can try it right now, and so it's there. But really what I was going to show here really just quickly was I can now set my default target inside of VS Code. If I go over here and do the debug thing, it'll take my Maui app and actually launch it right from VS Code. So it's the first time we actually have VS Code tooling built directly into VS Code. There we go. There's my Maui app. Hello, Bulgaria. And so I am technically out of time, and so I will stop. But I'm going to be around the rest of the week. If you have any questions about the web tech I showed, the AI tech I showed, we've got Maddie and David here for the Maui stuff. We've got Jeff here for ASP.NET. Please come find me at the show. I would love to answer your questions. Thank you for hanging out with me for the last hour, and thanks for having me here as well.